We're going to look at drawing ray diagrams for convex or converging lenses. I highly recommend that you have the fill in the blank PDF notes in front of you so that you can then fill in the blanks and see exactly what we're about to do. So first step we need to do is talk about what a ray diagram is. A ray diagram helps us draw lines to represent light to figure out how different lenses and mirrors will create images. First step is to learn the rules for drawing these lines. This will all make a whole lot more sense once we do it. These rules are not written anywhere in those PDFs, so you probably want to write these down. Step 1 for drawing ray diagrams is you're going to draw a line from the top of the object parallel to the lens, and you will refract or bend through the focal point. Step 2, draw a line from the top of the object through the center of the lens. And then step 3, where the lines converge or come together is where the image will be located. And you will always draw your image from the principal axis to the point of crossing. So the first one in the note says an object between the convex lens and its focal point. So here's one of our focal points. Here is the lens. So our arrow, which represents our object, is in between. Step 1 says to draw an arrow, or so draw a line from the top of the object parallel to the lens. Notice I went to a center line. We bend or refract through the focal point. Light goes through a lens, so you have to draw the light going through the lens. Step 2 is to draw a line from the top of the object through the center of the lens. You should notice here, these lines are not going to come together. Because of that, we will not have a real object or a real image. Real images are formed by converging light rays. Since our light rays are not going to converge, it cannot be real. Instead, it is virtual, which means we might see it, but it cannot be projected. To find our virtual image, we'll use dotted lines to represent the virtual, and we will extend only the refraction lines. So here's our first refraction line, and then this one is, since it's a straight line through, it refracts up through the line as well. Notice we have a crossing point. We have conversion, and so our image is located there. We draw the arrow starting from the principal axis up to where it converges. This creates a virtual, upright, and magnified image. Those are your three blanks. Why would the object be virtual? Because the real light rays do not converge. Hence you can see it magnified, magnifying lens. Our second one is going to be an object held between F and 2F. So here's F, so twice that distance, our object is between. Step 1, top of the arrow parallel to the lens, and then we refract through the focal point. Step 2, top of the lens through the center. Notice now we're converging in the real space. So again, here's real and here's virtual. So it is a real object. We draw it from where our principal axis would be down to where it converges. So this one is real. It is magnified. And now it's inverted, which just means upside down. Alright, last one is further out. So top of the line, top through the focal point, and then top through the center. So our image is here.